step 2, we go to a second loop, which means we will generate rules from the sets that we discovered in the first loop. We will take the unmarked sets so generate rules from sets in first loop. By combining, this is step 3. That was step 2, and this is step 3. Step 3 is second loop. Generates rules by combining unmarked sets from first loop. In other words, we go to 2 element sets similar to what we did in the a priori algorithm. Sorry. So in second loop, we're combining unmarked sets from the first loop, and this way we go to 2 element sets. So what we're going to do is take the sets that are not marked and combine them together. A1 is not marked, F2 is not marked. So we will take the intersection of these 2 sets, and that will be A1 and F2 together. That's what we showed on the Venn diagram in the beginning. A1 and F2 together. So we're going to take the intersection of A1 and F2. What will be the intersection of A1 and F2? We are looking for elements that are contained in both sets. X2 is contained in both of them, right? That would be A1 and F2. X2, X3, is this both of them? And what else? the intersection of A1 and G1? X2 is in both of them, and X4 is in both of them. Next is A1 and G2, right? Is there an intersection between these two sets? X3. X3. So this is equal to X3 here. Next, F2 and G1. So between F2 and G1, is there intersection? X2. Next, we'll combine F2 and G2. Is there intersection between those?
X3.
X3 and X5. F2 and G2. And the last one, oh, we don't have any more.
G1, G2.
Yeah, you can't do that. Right. We're not combining G1 with G2 because
There's same variable.
we can't combine G with itself. We are combining one attribute with another attribute, not attribute with itself. This would be like, I had the same question earlier today. G, let's imagine this is your eye color. These are customers and this is the eye color. Blue eyes, brown eyes, hazel eyes. How are you going to do both blue eyes and brown eyes? We can't have that. Hopefully we can't. I was told that we could actually, but it's not a good idea. So we're not combining G with itself or anything else with itself for that matter. That's it. We're only combining them with other attributes. So now we are going to do the same thing as we did in the first loop. We will extract certain rules and possible rules. The certain rules in the second loop from marked in second loop. Which ones are marked anyway? Is this set marked? Why?
not a
We are looking for subsets of the decision attribute.
It's not a
Is
subset.
this one a subset of either C1 or C2? No, so it's not marked. Is this one subset of C1? No. Is the subset of C2? No. How about this one?
C1.
Subset of C1. So this one is marked. Subset of C1 because C1 has the X3 in here. How about
C1.
this one?
C1.
Again, subset of C1 because the C1 has the X2 in here. Subset of C1. Is this one a subset?
No.
No. It's not a subset either C1 or C2. So certain rules we will create from the marked sets, which means the confidence is 100% for these rules. So the first marked set is this one, A1, G2. So the first rule will say A1 and G2 implies what? Implies what?
C1.
C1 because this is a subset of C1. And confidence is 100%. F2 and G1 implies what? C1. These are the certain rules. And now the possible rules. Possible rules from the unmarked sets. The first unmarked set is this. A1, F2. So A1 and F2 implies either C1 or A1 and F2 implies F2. And we need to specify the supporting confidence. What is the support for this rule? A1 and F2 and C1, all of them together.
Two.
That's hard to see now. That's A1, F2, and C1.
Oh, yeah.
A1, F2, and C1, one time. A1, F2, and
Yeah.
C1.
The next one.
And this one? Do you see any more?
No.
So that's 2. And the confidence is 2 divided by what?
3.
Why 3?
Because you F2 3 times.
Support
is
of the set on the left side of the rule, which is How many times we have A1 and F2 together?
3 times.
3 times.
Let's A1, F2.
The last one.
A1, F2, A1, F2, 3 times. So this is 2 over 3. Which is 66%. And now the next rule, support is what? A1 and F2 and C2 together.
Last one.
A1, F2, C2 only one time. And the confidence is 1 divided by the set on the left side, which is A1 and F2. We just check that's 3. Next rule is unmarked set A1 and G1. So this is going to be A1 and G1 implies either C1 or A1 and G1 implies C2. What is the support for this rule? A1, G1, C1 only happened once. Right here. A1, G1, C1. And the confidence 1 divided by the set on the left side, which is A1 and G1. 2. And next, A1, G1 implies C2. What is the support of that? A1, G1, C2, only once. Confidence is 1 divided by 2. Support of A1, G2, we already seen that that's equal to 2. And the last unmarked set is F2 and G2. So F2 and G2 implies either C1 or F2 and G2 implies C2. What is the support for F2, G2, C1? F2, G2, C1 only once. And confidence is 1 divided by left side, which is F2 and G2 together. 2. That's 2. F2 and G2 once, F2 and G2 twice. And this one, F2, G2, C2, all 3 happening only once together, divided by F2, G2, which was 2. So that's 50%. So now, we will go to the third loop.